Okay, morning guys, food. And now we're gonna finish up a speed control of DC motor calculations. So this is part 2. So ndiyagqibezela ke apha for a speed control. Then we'll start doing efficiency of DC machine. Okay, calculations, because I only do calculations. Besithethe nge series motor, and we did calculation on series motor on the previous video. Go part 1. To learn again also thetha ngentoni nge shunt motor. Okay, how do we calculate a speed shunt motor? Now, a shunt motor must you have a field coil or a field winding in parallel with a armature. Okay, hence we call it shunt motor. Okay. Let me draw the circuit into first. Okay, we see that umbane, okay, this supply up umbane. Okay, the current isuka from the source I load, and is split ibe ngu I armature, ibe ngubani ku I shunt. Guys, niyabona umahluko ke ngoku, the way you analyze a shunt motor is not the same the way we analyze a series motor, because upper, if siyabona, the current is not the same. Okay, I load is not equals to IA and is not equals to I shunt. Okay, what is happening upper, we can use Kirchhoff's current law. The sum of the current flowing towards the junction is equals to the algebraic sum of the current flowing away from that junction, of which is yabona ke ngokuphana ba I load ifana noba total current I shunt plus I armature. Okay, of which is eyona current esizoyidinga yabo IA. So IA is the subject of the formula. IA is equals to bani I load minus I shunt. Okay, because remember IA is something kasibala back EMF. RAC siyasitinge lo IA. Okay, and another thing, sometimes you are not given a shunt field current, of which is you can use Ohm's law. Because remember, this is a parallel circuit. If voltage across upper, you find a voltage across upper, you find a voltage across let me just correct something. If voltage across upper, iyafana ne-voltage across upper, but ayifani nalapha, because upper ukhona i-back EMF, so ndibonisa ngoku why ndisitsho njalo. Okay, V over R shunt. Okay, this is a formula from what? Ohm's law. Okay, but we cannot say I armature is equals to V over RA. This is wrong, guys, because remember, we armature, there is something called a back EMF that is opposing the supply voltage. The correct way would be to write this would be to say IA is equals to V minus E over R armature, yabo. But in most cases, you don't rely on this formula. Sorry, you don't rely on this formula, yabo. He has calculated armature current by looking at question by ithini question torque, or you come and manipulate upper this formula. Okay, then guys, another thing how do we increasing speed of a shunt motor. Okay, xa besithi draw a circuit, nansi circuit ozoyidrawa na. Into yenzayo uconnecta i-resistor, i-variable resistor in series with a field winding. Okay. Niyibona i-variable resistor yam once ibe in series with a field winding, yazi uba se-increase i-speed ngale circuit. Okay, before I continue with this, I would just want to go back a bit, ndilibele nje ucacisa le nto. Apha guys, kwi-shunt motor, RAC, armature circuit resistance, is equals to RA. It is not equals to RAC, R shunt plus RA. This one is wrong. Why? Because field winding ayikho part of the armature circuit. Nansi armature circuit ile, yabo, yona ikweyayo iloop, ikweyayo intoni iloop. Nansi loop ye field winding iyodwa, yabo. It's not part of the armature circuit. Hence we say RAC is equals to RA, yabo. Okay, so going back up again, let's call this a variable resistor RX, still nalapho RAC is equals to RA, because even though si-ede la resistor asiyi-edanga phi kwi-armature circuit, yabo, asiyi-edanga kwintoni kwi-armature circuit. Okay, what if we had to calculate a current yalapha, I shunt? We would have to say I shunt this time is equals to V R shunt plus RX, because kaloku le resistor si-ede in series with intoni field winding. That means a part of la circuit ye field winding, yabo. Then ke ngoku moving on, if we have to do a circuit for reducing the speed, okay, what we do is kasi reduce speed, sizoconnecta i-resistor in series, i-variable resistor in series nentoni ne-armature. Then ispeed sethu sizoreduceka, yabo. Nansi le variable resistor we added in series with intoni i-armature RX, let's call it. And then upper guys, in this case ke ngoku, it means that xa ndibala u-RAC is what RAC, sorry, is equals to RA plus R bani X. Yabo. So because kaloku le variable resistor, sorry, the delay yona, the variable resistor and the delay is part of the armature circuit, hence I have to add it and value RAC. Yabo. Because remember RAC will belong up here, V minus IA RAC. And then mhlawumbe ndibala u-RA ndibala u-E1 and RAC1 yabo kwi-first condition. Okay guys, now that we have talked about a shunt motor, I have shown you the different scenarios. We can start now to attempt a question. But a 240 volt DC shunt, okay, motor, yabo, that is important to know which type of motor you are talking about. Then, but it draws an armature. Notice they are being specific there. That is an armature current. That is not a load current, because they are specific to say an armature current of what? 18 amps from the supply. Then they say the resistance of the armature circuit. Okay, they have given us RAC in this case, because but here the resistance of the armature circuit, meaning the total resistance in the armature circuit is 0.25. And then but to calculate the resistance required in series with the armature to halve the speed. Yabo, they want us to halve the speed. Resistance required in series to halve the speed. When you want to reduce a speed, shunt, what you do is you connect a resistor in series with the armature. Okay, fine. Okay, if so, 1.1, if the load torque remains constant, okay, 1.1, meaning T1 is equals to T2. Okay, guys, if the load torque remains constant. And let us write our given. We are given a voltage, a supply voltage of 240 volts. We are given armature current. Let us call it IA1. Okay, which is 18 amps. Now, then we are given the armature circuit resistance. Okay, in this case, armature circuit resistance RAC1 is equals to 0.25. Okay. Then, but you must calculate a resistance in series, for that is the second condition. So, if first condition here to each. Is standard, Okay. Okay, engine 240 volts. Okay, then what they did is now with second condition, they say with second condition they added a resistance in series. Okay, Rx. And guys, what does that mean? It means that ORAC2 is equals to Rx and HO plus, and it you are adding you are adding a resistance P up, hence in city plus 0.25. Yabo thina mele sikhangele bani RAC2. RAC2. Once it's from an RAC2, we are able to make this subject of the formula. So formula the answer ka 1.1. Okay. Remember, sifumana njani RAC2 E2. Sifumana E2 V minus RAC2, RAC2. So finally, but ke ngomele siqale sikhangele E2 no let's sikhangele E2 IA2. Okay, so how can we do that? Maintaining a speed, we're gonna use this formula obviously to find E2. E1 over E2 is equals to flux 1 over flux 2 N1 over N2. Okay, the good thing about a shunt, guys, the good thing about a shunt, if supply voltage doesn't change, okay, I shunt will always be the same. I shunt 1 would be the same, because if a voltage I change, resistance field winding I change, I shunt will always be the same. If I shunt I change, that means flux 1 is equals to flux 2, and that's the characteristic of a shunt motor. A shunt motor, the field, the flux remains constant, unless otherwise. Hence we can say since it's a shunt motor, flux 1 is equals to flux 2, okay, meaning is their cancellation. So bano E1 E2, okay, then sebeno N1, sebeno N2, okay. What did they say about the speed? They said the speed is halved. That means the speed, let's say if besingu 1,000 revs per minute, sehliswe ngo-half sangu-500 rev per minute, meaning N2 is half. Let's say it's half. Half must 0.5 N1. Okay, so we can what we just did, we represented N2 in terms of N1. E1 over E2 is equals to N1, and then N2 in terms of N1 is 0.5 N1, of which is all N1 by cancellation. Into one ke ngoku ndishota ngayo, ndishota go E1 kuze ndifumane ubani E2. What I can do is calculate E1. E1 is given by V minus IA1 RAC1, and which is 240 minus amateur current yethu yokuqala sesayinikwa 18, then ke sanayo into amateur circuit resistance was 0.25. Okay, so E1 would be, let's calculate that, would be 240 minus, okay, that is gonna be 235.5 volts. Okay, we have found E1. We have found E1. Now we can substitute the formula now. Then for E2. So 235.5 over E2 then equals to 1 over 0.5. And then we cross multiply. Plus a cross multiply, I say okay, E2 is gonna be 235.5 times 0 cross 0.5, which is gonna be 117.75 volts. Okay, guys, we have found E2. Now that we have found E2, sishota ngo-IA2 sizobala lo RAC2, ayna. Okay, so how do we calculate IA2? We look at the torque, but the load torque remains what? Constant. Meaning which T1 is equals to T2. Then kasi faka la formula torque T1 over T2, then flux 1, I armature 1, then flux 2, I armature 2. We say that T1 no T2 bayalingana, so we can cancel. With flux mostly, this is a shunt motor. If flux with shunt motor remains constant, then we can cancel. Okay, that means we have 1 is equals to, because Lena Moscow's cancellation is equal 1, yeah, is equals to IA1 ban 18. Let me check. Yes, 18 IA2, meaning which can IA2 naye ungo 18 amps. Yeah. Now we can calculate RAC2, because we like the formula, ne? E2 is equals to V minus IA2 RAC2. We can calculate RAC2. E1 ban 117.75 equals to a supply voltage being 240 now. 240 minus 18 RAC2. RAC2 kengoku is gonna be 117.75 minus 240 over negative 18. Okay, let's punch that. There is gonna be 6.792 ohms, can be round into 3 decimal. Okay, meaning remember sibuyela where we said RAC2 is equals to RX plus 0.25, and of which is yamazi R bani C2 ngu 6,792 equals to Rx plus 0,25. Therefore, ORX lo simfunayo le resistance kumele in series is gonna be 6,792 minus 0,25 is gonna be equals to 6,542 ohms. Now, that is question 1.1. Okay. The next question says 1.2. The next question says the load torque is proportional to the speed, meaning if a speed is increase, the load torque here increase. If a speed is decrease, the load torque here decrease. Okay. Assume the field system is unsaturated. Assuming that the field system is what? It's unsaturated. Okay. So, torque again is gonna be T2 is gonna be 0,5 T1. Why is that? It's because since there is a proportion between speed and torque, Mosesity statement, the speed is halved. Okay, meaning if the speed is halved, the torque is also halved. Yabo, eminisha londo moslondo. Okay, so kasibuyela ke ngoku sifuna ubalo Rx for 1.2. Kasibala ke ngoku sithi T1 over T2. Flux 1 IA1, flux 2 IA2. Guys, this question is a continuation. E1 lo besimbalisa usekhona kule question. Upper, even though they are saying unsaturated, if field strength I can change because if I shunt 1 usazoba equals to I shunt 2. The only time I shunt field current inga-change is when basixelela uba I shunt resistance ibingaka yangaka ngoku, or basixelela uba I supply voltage ibingaka then change yangaka yabo, because remember kawubala shunt current is V over R shunt. But if it's two factors has changed, that means the field current I change, and if a field current I change, that means if field strength le winding I change, because remember electromagnet kawufuna change magnetic field strength, you increase or decrease the current. If the current remains the same, if field strength will remain the same. Okay, upper we can say T1 over 0,5 T1, because T2 I have placed it in terms of T1. Then sibeno 18 amps ka IA1. Then sibeno IA2. Tina sifuna IA2, so that sifuna IA2 na. So that sizosebenzisa le formula E2 is equals to V minus IA2 R AC2, because because into etshintshileyo apha yabona into ezotshintsha yile current, hence ke ngoku u-RAC2 akazofana na ku question 1.1. Okay, These cancel, then we cross multiply. IA2 is gonna be 18 times 0.5, which is 9 amps. Then okay, sibuye ke sizobala u-RAC2 omtsha, which is gonna be E1 besimbalile mos ku-117 sorry, your E2 besimbalile, so not E1, E2 besimbalile. Where's E2? 117.75. Okay, 240 minus then 9 RAC2. Then go minus value RAC2 omcha 117.5 minus 240 over negative 9. Okay. 117.5 minus 240 over negative 9. That is going to be 13.611 ohms. Meaning RAC2 is equals to RX plus 0.25. And but sesimbalile 13.611 RX plus 0.25. ORX is therefore equals to 13.611 minus 0.25. That is going to be 13.361 ohms. Okay, guys, that is the end. Guys, hello, sorry guys, I just made a substitution mistake up now. I was supposed to say E2 is 117.75, so I missed that 7. So let me just rectify it. The answers fun in a memo or something. Yeah. Okay. So this should be, let me punch it. Sorry. 117.75 minus 240 over negative 9. That is gonna be 13.583. Okay, upper bekumele ndifake bani 13.583. Then meaning ORX is bani 13.583 minus 0.25. That is gonna be 13.333 ohms. Okay, guys, that's it. Then we're done with the speed control. Guys, and by Tutarishaya College, I will send you questions from previous question papers as exercise. If you have any challenge, then sizo communicate. Communicate.